Welcome back to my YouTube channel. Today we have an algebraic equation with complex roots before us to solve. And the question is y minus 4 to the power of 4 equal to y to the power of 4. What then would be the values or the value of x? What would be x? So we are going to see the different values of this y. Let's go ahead. So I bring out my question. I have y minus 4 to the power of 4 equal to y to the power of 4. So what I'm going to do next is to transfer this y to the power of 4 to the left hand side. So the equation becomes y minus 4 to the power of 4 minus y to the power of 4. Now equal to 0. So what I need to do is, don't forget that, remember from indices that a to the power of n is the same thing as a to the power of m bracket n. So if I have mn, I can break it up to a to the power of m and then to the power of n. So this law of indices, this rule of indices is going to be applicable to both terms of the equation. Okay, so to these two terms. So we have here, I'm going to split this to become y minus 4 to the power of 2, all now to the power of 2. Okay, then of course I have y to the power of 2 all raised to the power of 2 equal to 0. So this now becomes a difference of 2 squares. So I have, this is now using the difference of 2 squares, using the difference of 2 squares. I will be able to further simplify the left hand side of the equation. So how do we, what is this a difference of 2 squares? So if we have a squared minus b squared, the result will be a minus b times a plus b. So that is the difference of 2 squares, where in this expression a will be standing or representing y minus 4 squared, and then of course b will be represented by y to the power of 2. So if I come over here to continue the solution, so the left hand side, we're going to simplify the left hand side using this difference of 2 squares. So it's going to become y minus 4 squared times y minus 4 squared. Okay, this is a and this is b. So a is this, then minus y squared, close the bracket, then have y minus 4 squared plus y squared, close the bracket, equal to 0. So this is what we have. So we will further go ahead to expand this y minus 4 squared. So we have y minus 4 squared times y minus 4 times y minus 4, then minus y squared times y minus 4 times y minus 4 plus y squared equal to 0. So on opening up these brackets, I'm going to have y multiplied by y will be y squared, y multiplied by minus 4y will be minus 4y, minus 4 times 4y will be minus 4y, and then of course minus 4 times minus 4 will be plus 16. I'll close that bracket. And of course, sorry, I'm going to write minus y squared, then close the bracket, and of course do the same thing to the second bracket. So we have y squared minus 4y, then plus 16 plus y squared, and then close the bracket equal to 0. So what we have here now is that minus y squared and y squared will cancel each other out. So we have minus 4y minus 4y plus 16 multiplied by 2y squared minus 4y minus 4y plus 16 equal to 0. Okay, so this will give minus 8y plus 16 in one bracket. Then in the second bracket I have 2y squared minus 8y plus 16 equal to 0. So there are two different factors here. So I will move over and continue the solution on this side. So there are two different factors. So what this means is that the first factor, okay, let me move over here. So it's going to be minus 8y plus 16 equal to 0. And then, or 2y squared minus 8y plus 16 equal to 0. So this is important because if from here, if we have a dot b to be equal to 0, what that means is that a will be equal to 0 or b will be equal to 0 or both will be equal to 0. So if you have a dot b to be equal to 0, it's either a equal to 0 or b equal to 0 or both are equal to 0. So from this we have that minus 8y will be equal to minus 16. Dividing both sides by minus 8 will give us minus 8. So this and this will go. So y will give us 2. And then of course, we can call this case 1. And then we'll move over to case 2, where we have 2y squared minus 8y plus 16 equal to 0. So from here, we need to, okay, first we can see that each term of the equation is divisible by 2. So we have 2y squared all over 2 minus 8y all over 2 plus 16 all over 2 equals to 0 all over 2. So this will give y squared minus 4y plus 8 equal to 0. Of course, 0 divided by any number is 0. So I'm going to continue the solution on this side. So I have, so from here, first we need to know, to find out if this quadratic equation is factorizable. Does it have factors? How do we know if it has factors? So there is a property of quadratic equation that enables us to easily at a glance know if a quadratic equation has factors. And that property is known as the discriminant. Discriminant D. And this D will be equal to b squared minus 4ac. And then of course from this equation, a is 1, b is minus 4, a is the coefficient of y squared. The value of a will be the coefficient of y squared, and in this case the coefficient of y squared is 1. The value of b will be the coefficient of y, and the coefficient of y is minus 4. And of course c will be the constant term of value, which in this case is plus 8. Now once you put in these values into this formula, we are going to know or get the value of d. And the value of d will tell us if this equation has factors, common factors, okay? Or, I mean, whether if this equation can be factorized. Let me just put it that way. So, what will be the value? The value of b is minus 4. So, you have minus 4 squared. Then minus 4 times the value of a, which is 1. And then the value of c is 8. So, you have 16 That's negative 4 squared is 16 minus 4 times 1 is 4, then times 8 is 32. So the result here is minus 16. Now, you see minus 16 is less than 0. So now the rule is that if D is greater than or equal to 0, then we have real roots. Real root, that means real numbers. Real numbers. And when we talk about real numbers, it's either negative or positive. Okay? Okay, so then if D is less than 0, then we have complex roots. Complex roots. Complex roots can also be referred to as imaginary roots. Okay, good. So now, from what we've done here, we can see that this equation is going to have complex roots. So how do we find the complex root? We just quickly go back to the quadratic formula. So we use the quadratic formula. And the quadratic formula is x equal to minus b plus or minus square root of b squared minus 4ac all over 2a. You can see the discriminant featuring prominently here. Okay, so from there, we can come over here and continue the solution. Okay, so already we know that b squared minus 4ac is minus 16. Then of course we have minus b plus or minus, and then of course b is minus 4. So from that end, since we are looking for y, so our y will be equal to, that's in the equation we have y. So we represent this x with y, okay? And then of course we have our values, minus 4 plus or minus square root of minus 16. I told you already we have the value of the discriminant. We have the value of discriminant, which is b squared minus 4ac. So there's no point repeating it again. Okay, so we have y will be equal to plus 4 plus or minus square root. So we break up this minus 16 to 16 times minus 1, then over 2. So y will give us 4 plus or minus. The square root of 16 is 4. The square root of minus 1 is I. Yes, the square root of minus 1 is I. So over 2. So we have y equal to 4 over 2 plus or minus 4i over 2. So y will be equal to 2 plus or minus 2i. So here are the two complex roots. So you have the plus and the minus. So we have y equal to, so to summarize, so there are three values for y now. So we have y1 will be equal to 2, y2 will be equal to 2 plus 2i, and then y3 will be equal to 2 minus 2i. So these are the solution of our complex quadratic, complex algebraic equation. Thank you very much for staying through. I'll see you in the next class. Please, before you leave, kindly subscribe, turn on the notification bell, and give me a like or thumbs up. I love you.